Hi, my name is Matt Bowler, and in this video we will be discussing, configuring, and verifying some spanning tree security features. The features that we'll be taking a look at are listed right here in blue. We'll look at PortFast, RootGuard, BPDUGuard, Storm Control, and Switchport Modes. Let's start out here by taking a look at the topology. I have four physical switches running at my home lab right now, so this diagram is just for reference. We've got two distribution layer switches, 3550s, that's a layer 3 switch, and then we've got two access layer switches which are 2950s. We're running a rapid spanning tree protocol here between all the switches. My laptop will be what I'll be running the management features from. They're all running on the common subnet of 192.168.1.0 with a 24-bit mask, and the IP addresses start in descending order with the distribution switch A, the 254 address, B is the 253, and the access layer switches are 252 for switch A and 251 for switch B. You can see my computer over here with the 100 address. On the port channel connection between the distribution layer switches, we will be enabling storm control for broadcast, setting the threshold to 50%, and we'll be hard coding the switchport mode to no negotiate. Its default setting is dynamic desirable, and that will allow any switch that connects to form a trunk link. If one side requests that, it's going to go ahead and form that link, and that's not something that we want. So we're going to hard code no negotiate, so dynamic trunking protocol is disabled, and no DTP packets are exchanged. On the fast Ethernet 10 and 11 ports on the distribution layer switches, we will enable RootGuard, so that if either of these switches for some reason is compromised, and or if someone tries to connect another switch into these ports, it's going to block the access layer switch from becoming the root primary. So we can see right here on the distribution switches, they're all running on VLAN 1, and the IP addresses are assigned to the VLAN 1 interface, the SVI. So we've got distribution switch A is the root primary, B is the root secondary, and these access switches are assigned the second to highest values for priority. So those hard-coded like that are not going to try and take over the root, but we will simulate what happens if someone changes that, or if they were to introduce a switch with a lower priority than one of these distribution switches. So we'll see what happens if an attacker were to try and come in and compromise our spanning tree topology here. From the access layer switches, we'll be enabling BPDUGuard, which if someone connects a switch to that on an access port, it's going to just shut the port down and go into error disable. We'll also be shutting down our unused ports, which is the main line of defense there, and we'll be hard coding those ports to access mode. So redundancy, yes, it's good, but it's something to keep in mind. You want to have many layers of security there to prevent an attacker from coming in and compromising your spanning tree topology. Let's start off here by creating this port channel and the trunk between the two distribution layer switches. I'm going to telnet into the switch A using a password of Cisco, all lowercase. That's what I use, common to all my labs out there. Just keep it simple and consistent, and you won't run into any problems when going through the lab environment. I'm going to open up connection to the switch B as well. Go ahead and mirror these configurations. So from switch A, we'll just do a show spanning tree to show you what we've got going on here. We can see that switch A is the root bridge, and all of its ports are forwarding from the switch B at the distribution layer. You can see we've got the two separate connections here, fast Ethernet 1 and 2. Those are the connections between the two distribution layer switches here. And when we create that port channel, we'll see those two physical ports become one logical port. Let's go ahead and get that set up. We'll start on switch A and go into configure terminal mode and enter the interface range for fast Ethernet 0, 1, and 2. I'm going to enter the channel group, the assigned number of 1, and we'll hard code it to the mode of on. It's going to create the port channel interface 1, as you can see right here. I'm going to go ahead and just mirror that configuration on the distribution layer switch B. So the interface range, fast Ethernet 0, 1, and 2, and the channel group 1, mode of on. If I do the show spanning tree here once more, we can see that those two fast Ethernet interfaces are now one logical port channel interface. Do a show span over on here as well, and you can see that reflected in the output there.